In this tutorial, we're going to complete the square to solve for x when a is not 1. So this example is on page 96 and it's number 6. So I want you to notice that here a is not 1 but instead it's 3. So if we want to solve that problem, we need to first get all of our terms on one side. So I'm going to start off by subtracting 8 on both sides. When I do this, I end up with 3x squared plus 8x minus 12 is equal to 0. Now I have this in standard form, and I'm ready to take care of this 3. I'm going to take care of it by dividing both of my sides by 3. As long as I do it to both sides, it keeps my equation equal. When I divide by 3, I need to make sure I'm dividing each and every single term. So my result will be x squared plus 8 thirds x minus 4 is equal to 0. Now that I have an equation in standard form where a is 1, I can continue as usual and complete my square. So I'm going to go ahead and add 4 to both sides to get x squared plus 8 thirds x equals 4. I'm going to leave some space because I need to add another number to my left side to turn that into a square. So I'm going to try to figure out the little squares that will fit into my picture. So in order to figure that out, I'm going to need to find b over 2 squared. In this case, b is 8 thirds, so I need to divide it by 2. 8 thirds divided by 2 squared is going to be 8 over 6 squared. If I simplify the inside, I'm going to get 4 thirds squared. And now to get rid of the squared, it'll become 16 over 9. So I'm going to put 16 over 9 on both sides. And since this side is now a perfect square, I can replace it with a binomial squared. And let's figure out what's on this side. 4 plus 16 over 9, the denominator is 9, so I have my 4 over 1. I'm going to multiply top and bottom by 9 to get 36 over 9. And now I can add. From there, I'll get 52 over 9. Now let's figure out what has to be added or subtracted from x. That term is simply b over 2. But if I look at what I had before, there was a b over 2 embedded on the inside. So here's my b over 2, b over 2, b over 2, b over 2. And rather than doing all of that work again, I can just write it as 4 over 3. So here is plus 4 over 3. Now that I have this equation, one of my last steps is to take the square root of both sides. When I do this, it undoes this square, and so I'm going to be left with x plus 4 thirds equals plus or minus root 52 over 3. So I need to take the square root of the very top number and the bottom number. And it turns out that bottom number is a perfect square, so we end up with a 3. Now, we're going to subtract 4 thirds from both sides. And I'm going to take my work up here. And I'm going to get x equals negative 4 thirds plus or minus root 52 over 3. Notice the common denominators. That allows us to combine everything together. And so we now have x is equal to negative 4 plus or minus root 52 all over 3. This is a pretty good answer. But if you wanted to, you can look at the 52, and see that it's made up of 4 times 13, which is 2 times 2 times 13. Since there are two 2's in there, one can come out and the other one can go away. So here our other answer could be -4 plus or minus 2, the 13 is still trapped, all over 3. And this would be a more simplified version, but these two are equivalent and either or is fine.